The toll of space. How 288 days in orbit changes the human body. The effects of long-term space travel on astronauts. The struggles of returning to Earth. NASA astronauts Butch Wilmore and Sunita Williams recently returned to Earth after being stranded aboard the International Space Station (ISS) for 288 days, despite originally planning for only an 8-day mission. Their prolonged stay in microgravity has led to significant physical and physiological changes, highlighting the immense impact of space travel on the human body. They sleep in small, phone booth-sized compartments, often requiring eye masks and earplugs to block out noise from ventilation systems. Sleep deprivation leads to weakened immunity, memory issues, and increased fatigue, all of which Williams likely experienced. The impact of space diets, weight loss and nutritional deficiencies. Williams appeared visibly thinner upon return, likely due to a combination of nausea, appetite suppression, and the unappealing nature of space food. Freeze-dried and rehydrated meals lack the texture and flavor of fresh food, making it difficult for astronauts to maintain their usual caloric intake. Many lose about 5% of their body weight during extended missions, which can be concerning given their already low fat reserves. Vitamin deficiencies and bone weakness. Astronauts also suffer from vitamin D deficiencies due to the lack of sunlight exposure. Although they take supplements, the absence of gravity affects the body's ability to retain calcium, leading to increased risk of osteoporosis. Space radiation. A silent threat. Perhaps the most dangerous aspect of long-term space travel is radiation exposure. Unlike Earth, which is shielded by its atmosphere and magnetic field, space exposes astronauts to 10 times the amount of radiation they would normally experience on the planet. This increases the risk of cancer, cardiovascular diseases, and cognitive decline. DNA damage comparable to heavy smoking. Studies have shown that astronauts experience DNA damage at levels similar to those of heavy smokers. NASA's research on astronaut twins Scott and Mark Kelly revealed significant genetic changes after Scott spent a year in space. His telomeres, protective caps on chromosomes, temporarily lengthened but quickly shortened upon return, raising concerns about long-term health risks. The psychological toll of isolation. Prolonged isolation in space can lead to depression, anxiety, and cognitive impairment. Williams's dramatic physical transformation is not just a result of physiological stress but also the psychological strain of being away from family, confined in a high-risk environment for nearly a year. Conclusion. The case of Butch Wilmore and Sunita Williams underscores the profound effects of long-term space travel on the human body. From muscle loss and cardiovascular issues to radiation-induced DNA damage and premature aging, space presents unique challenges for human health. As NASA and other space agencies push toward longer missions to Mars and beyond, understanding and mitigating these effects will be crucial to ensuring astronaut safety and well-being.